We are going to start the lecture 2 of chapter 6 class 9 mathematics, lines and angles. So the first definition over here we have, it is parallel lines. So the parallel lines are if two lines are given to us and they lie on the same plane and they do not intersect when produced on either side, then the lines are said to be parallel to each other. So this is represented over here. This is line L and this is line M. They lie on the same plane, and if we produce this line, means we extend these lines infinitely like this, then in this finite plane they are not intersecting anywhere. Next is the definition of a transversal. A transversal is a straight line which cuts two or more straight lines at distinct points. So we are saying these two lines are there. If this line cuts over here, then this line is called a transversal. One thing is, we are talking about, if suppose these are the two lines, then this is the line, that is the transversal. But if I am talking about this line, it is intersecting at the same point where these two lines are intersecting, then this is not a transversal. We are saying these three lines, these are concurrent. So that is why it is mentioned over here, a straight line which cuts two or more straight lines at distinct points is called transversal, that it must intersect them all at the distinct points. Next we have is the definition of pair of corresponding angles. So suppose two lines are there, A and B. This line A is there and line CD is there. So and a transversal is given. This is T is the transversal. So different angles are marked over here. We are saying this is angle 1, 2, 3, 4 and all these are marked over here. So angle 1 and angle 5, when we are talking about, these are the two lines, this is the transversal, then corresponding to this angle 1, this angle, these two angles, these are called the corresponding angles. Then if we are talking about the angle over here, suppose it is angle 4 and this angle we are saying this is angle 8, then these two angles, then 4 is corresponding angle, 4 and 8, this pair is called the pair of corresponding angles. Similarly, if we are talking about, suppose this angle, this is our angle 3, then corresponding to 3, now the corresponding angle is 7. So 3 and 7, they are the corresponding angles. And likewise this angle over here, it is, we are writing this is angle 2, then the corresponding angle over here, this is 6. So these two angles, these are the corresponding angles. So this is mentioned over here that 1, 5, 4, 8, 2, 6 and 3, 7, these are the corresponding angles. Next is the pair of alternate angles. So if we look at this figure in this form, that this is A, E, F, this is A, E, F and D, then these two angles, the pair of these two angles, these are called the alternate interior angles. Why interior? Because these are in the angle AEF. These are inside the angle this is inside of angle this. So these two angles, these are called the alternate interior angle. Similarly 4 and 6, angle 4 and 6, they are called the pair of alternate interior angles. So we have two pairs, 3 and 5, 4 and 6. Next is pair of consecutive interior angles. So consecutive interior angle means we are talking about, these are pair of alternate interior angle. This is consecutive interior angle. Consecutive means next. So we are saying 4 and 5, these are consecutive interior angles. Similarly, we are talking about 3 and 6, these are consecutive interior angles. Now the next we have is the corresponding angles axiom. So this is M axiom. We need not to prove this. So what we are saying is that if a transversal cuts two parallel lines, this transversal is given AB and CD are now two parallel lines. In the previous case, we are not talking about parallel condition. This is two parallel lines are there. And we are having a transversal over here. This line T is the transversal line. Then we are saying that the pair of corresponding angles are equal. The corresponding angle over here, it is 1 and 5, 4 and 8, 2 and 6, 3 and 7. So these pair of angles, these are equal angles. So this is our axiom, that if two lines are parallel, then this parallel condition is very important over here. This thing holds only when the two lines are parallel and transversal T is there, then the corresponding angles, they are equal. Now if I talk about the converse of this, then we are saying if a transversal T cuts two lines AB and CD such that these angles are equal, these are basically the corresponding angles, then we are saying then AB is parallel to CD. So this is just the converse of this axiom. Now next is a theorem. The previous result, it was an axiom, we need not to prove that. Now next is a theorem. So it is, if a transversal intersects two parallel lines, then alternate angles of each pair of interior angles are equal. So what this thing means, this is, we are saying pair of alternate interior angles, they are equal. Again, this condition that two parallel lines, this is very important over here, that this thing holds only when their lines, they are parallel. So again we are considering two parallel lines AB and CD. A transversal T is given to us and we have marked the angles over here. Now from the axiom we know that angle 1, because both these lines, they are parallel, so what we get is angle 1 is equal to angle 5, angle 4 is equal to angle 8, angle 7 is equal to angle 3, and angle 2 is equal to angle 6. Why? Because these are the corresponding angle, and corresponding angle axiom we are talking about, it says that these angles, they are equal. Now what we have to prove is, we have to prove that angle 3 is equal to angle 5 and angle 4 is equal to angle 6. Now if we look at the angle 1 and 3, then angle 1 will be equal to angle 3. Angle 1 is equal to angle 5. Why? Angle 1 is equal to angle 5 by corresponding angle axiom, and angle 1 is equal to angle 3 because they are vertically opposite angles. We are saying both these angles, they are vertically opposite angles, so they are equal. So what we get is angle 3 is equal to angle 5. So this is the first part we have to prove. Similarly, we are saying angle 4 and angle 2 are vertically opposite angle, angle 2 and angle 6 are corresponding angle. Over here, if we look at the figure, 4 and 2 are vertically opposite angles, angle 4 and angle 2 and angle 6 are corresponding angles. So what we get is angle 4 is equal to angle 6, and this proves our theorem. The next theorem we have, if a transversal intersect two parallel lines, then each pair of consecutive interior angles are supplementary. So again, two parallel lines are given to us and a transversal is given to us, and we have to prove that the pair of consecutive interior angles are supplementary. So consecutive interior angle, it is angle 3 plus angle 7. We have to prove angle 6, that is equal to 180 degree, and we have to prove angle 4 plus angle 5, that is equal to 180. 4 and 5, and it is 3 and 6. These are consecutive interior angles. Their sum is 180 degree. So to prove this, how we are going to start is, we are saying the sum of angle 3 plus angle 4, that is equal to 180 degree, because it is a linear pair. Next we have angle 4, that is equal to angle 6. Why? Because angle 4 I am talking about and angle 6 I am talking about. These two angles, these are alternate interior angles. So these two angles, they are equal. So what we get from these two result is that angle 3 plus angle 6, that is equal to 180 degree, and this is what we have to prove, that angle 3 plus angle 6 is equal to 180 degree. Similarly, we have to prove that angle 4 plus angle 5 is 180 degree, and to prove this we are considering again that EF stands on CD and angle 6 plus angle 5 is equal to 180 degree. Why? Because it is a linear pair. Now angle 6 and angle 4, they are equal because they are alternate interior angle. The same reasoning is there as we have done earlier. Same reasoning is there, alternate interior angle, angle 6 and angle 4. So if we substitute this value over here, you will get angle 4 plus angle 5 is equal to 180 degree. Next theorem is, if a transversal intersect two lines making a pair of alternate interior angles equal, then the two lines, they are parallel. Now this is just the converse of the previous theorem. We are saying now the alternate interior angles are equal and two lines are given. It is not given that they are parallel. What we have to prove is that two lines are parallel. So we are saying these are the two lines A, B and CD given to us. The transversal is given to us and we have marked these angles. Further, it is given to us that alternate interior angles, they are equal. So alternate interior angles are equal means we are talking about angle 3, that is equal to angle 5, and we have to prove that the lines A, B and C, D, they are parallel. So what we have to do is, we are saying angle 3 is equal to angle 5. This is given to us, that alternate interior angles are equal, and we are saying angle 3 is equal to angle 1. Angle 3 and angle 1, they are equal because they are vertically opposite angles. So from these two results we get that angle 5 is equal to angle 1, and angle 5 and angle 1, if we look at, this is angle 1, this is angle 5. So if these two angles, they are equal, we know that by the corresponding angles axiom. We have done it in two parts. This is basically the converse of corresponding angle axiom. We are saying that AB is parallel to CD because corresponding angles are equal. Similarly, next we have is, if a transversal intersect two lines, again two lines are given, it is not given that they are parallel. So we are saying the two lines are AB and CD. The transversal that intersects over here, it is T over here, in such a way that pair of consecutive interior angles are supplementary. So pair of consecutive interior angles are supplementary means angle 4 plus angle 5, it is given to be 180 degree, or we are saying angle 3 plus angle 6, it is given to be 180 degree. So what we have to prove now is, we have to prove that these two lines A, B and C, D, they are parallel to each other. Now we are saying, since EB is stands on the line T, we are talking about this EB, this stands on this line T. So what we have is that angle 1 plus angle 4, that is equal to 180 degree. Similarly, we are given that angle 4 plus angle 5 is 180 degree. So if we equate these two values, we get angle 1 is equal to angle 5. We are saying angle 1 plus angle 4 will be equal to angle 4 plus angle 5. So 4 gets cancelled, angle 4 gets cancelled, and we are left with angle 1 is equal to angle 5. And what is angle 1 and angle 5? These are basically these are the corresponding angles, and by corresponding angle axiom we are saying AB is parallel to CB. So we have basically used the corresponding angle axiom to prove this result. Next we have to prove is that two lines which are parallel to the same line are parallel to one another. So we are saying that we are given three lines L, M and N, and L is parallel to N and M is parallel to N, and we have to prove that these lines L and M, they are parallel to each other. So what we are going to do, we are going to construct a transversal over here, and to prove that these lines are parallel, we look at the angles. These angles we have marked over here 1, 2 and 3. Now it is given to us that L is parallel to N. If L is parallel, this line L is parallel to the line N. If these two lines are parallel, then we are saying that angle 1 is equal to angle 3. Why? Because these are corresponding angles. And similarly, M is parallel to N. The line M is parallel to N. So what we get is that angle 2 is equal to angle 3. Now from these two conditions, 1 is equal to 3 and 2 is equal to 3, these two conditions imply us that angle 1 is equal to angle 2. So for the line L and M, this T is a transversal, and angle 1 is equal to angle 2, and angle 1, angle 2, these are the corresponding angles, and corresponding angles, they are equal. And if corresponding angles between two lines are equal, then we know that from the corresponding angle axiom, we know that the lines are parallel. Now the next we have is, if a line is perpendicular to one of the two given parallel lines, then we have to prove that it is perpendicular to other line also. So we are saying a line M is given to us, another line L is given to us, and the angle between these two lines is, this angle is 90 degrees. Now a line N is given to us which is parallel to, this line N is parallel to M. So we have to prove that the angle between the line M and N, L, that is also 90 degrees. So what we see, this angle is angle 1, this is angle 2. Both these lines, these are parallel. So these two angles 1 and 2, these are the corresponding angles. And we know for the parallel lines, the corresponding angles are equal. So if angle 1 is 90 degrees, then this implies that angle 2 is also 90 degrees. Now in the next question, we have to prove that if two parallel lines, the parallel lines that are given to us, we are saying A, B and C, D, if they are cut by a transversal, we are saying the transversal is T, then we have to prove that the bisector of any pair of interior angles are parallel. So suppose we are considering the interior angle AEF, this AEF, and second is DFE. These angles we are considering, and the bisector of these angles we have drawn over here. These are the bisectors of these angles. So what we have to prove is that these two bisectors, that is the line, these lines, that is GE is parallel to FH. Now what we know is that when the lines AB and CD are parallel to each other, then these angles, this angle and this angle, we are talking about angle AEF and angle EFD, they are equal. These two angles, they are equal. Suppose I am saying this, its value is x, then this value is also x. Now GEF, that GE is the bisector of the angle. It means this angle we have, the angle over here, that is GEF. The value of this angle is x by 2, and similarly the value of the angle EFH, this angle we are talking about, it is also x by 2. So if I look at the figure like this, that this is G over here and E over here, and next we have F over here and H over here. We are talking about these two, and this is the line we are having T. What we are saying, we are considering now this is GE as a line and FH as a line, and T is now the transversal for these two lines, and what we have, this angle is x by 2 and this angle is also x by 2, and these two angles, these two angles, these are alternate interior angles corresponding to the lines GE and FH and transversal T. Now as the alternate interior angles, they are equal, so we have these two lines GE and FH, these are parallel. Now in this next question, we are given two lines AB and CD. This AB is a line and CD is a line, and a transversal is given to us. We are considering two corresponding, the pair of corresponding angles. Suppose these angles I am talking over here, these are the corresponding angles, and these lines are the bisector of the corresponding angles. It is given to us that these two lines, these are parallel, that is bisector of the pair of corresponding angles, they are parallel. We have to prove that the given lines are parallel. We have to prove that these two lines we have to prove are parallel to each other. Now this line PQ, this is also transversal for the lines EG and FH. We are talking about these two lines EG and FH. We are saying this T is also transversal for these two lines. So we have angle PEG. We are talking about the angle PEG, that will be equal to the angle EFH. The angle EFH we have over here. We are saying that these are the two lines we have. Suppose I am extending these lines in both the directions, and this is the transversal over here. This is EG and this is FH. This is transversal T. Then these two angles, these lines, these are given to be parallel. From this condition we are talking about. So we are saying these two angles, these are equal because these are the corresponding angles. Now this EG, this is bisector of the angle. Suppose I am drawing another line over here. Suppose I am drawing this line over here, and we are saying suppose this line is, this point is B, and we have drawing this line over here, and this point is T. We know that this G is the angle bisector. It means these two angles, if this angle is x, then the value of this angle is also x. The value of this angle is x, then the value of this angle is also x. So what we get is, we have written over here that angle PEG and EFH, they are equal because they are corresponding angle, and this implies us angle GEB and angle FHFD, these are also equal. So what we get is that if we square or if we double these angles, or we are saying we are adding these angles, so what we get from this is that this whole angle PEB, this whole angle, we are saying its value is now 2x, and similarly the value of this whole angle is also 2x. We are saying we have considered the angle PEG as x, and from that we are getting both these angles, these are 2x. So finally what we get from this is that I am explaining you over here that these two lines are given to us. We are saying this is the transversal over here, this is the bisector of this transversal, this angle, this is bisector of this angle. We have started that this angle is x, we are saying this angle is also x, this angle is x, this angle is also x. So what we have obtained that this whole angle is 2x, and over here this whole angle is 2x. So both these angles, these are equal, and these are the corresponding angles for the lines A, B, C, D, if we consider T as the transversal. So if these two angles, these corresponding angles, these are equal, so by the corresponding angle axiom we say that AB is parallel to CD. In the next question we have, if two parallel lines are intersected by a transversal, we are saying two parallel lines AB and CD are given to us and they are intersected by a transversal T, then we are given that EH, this is bisector of the angle FEB, then this GE, this is bisector of angle AEF. Similarly we draw the bisector of all these interior angles. Then we have to prove that this figure we obtain over here, this is a rectangle. We have to prove that this region or this figure we are obtaining over here, this is a rectangle. So what is given to us is that AB is parallel to CD. So what we have over here, that angle AEF, we are talking in this figure that this angle AEF, that is equal to angle EFD, and as FH is the bisector of this angle, so this is, we are saying, suppose this angle is x, this angle is also x. Next thing we have is, we are talking about these smaller angles over here that I have marked with green. So this angle will be x by 2 and this angle will be x by 2. Both these angles will be x by 2. So, but these are the alternate interior angles when we consider the transversal EF cuts EG and FH. If we are considering that these are the two lines EH and GE, if we consider these as two lines, then we are saying then T is the transversal for these lines. Now these two angles, these are x by 2 and x by 2 that I have marked with green. So what we get is, what we get from this is that EG is parallel to FH. With the similar reasoning, we can say that EH is parallel to FG. Similar kind of thing we have also proved in our previous question, that these two, these are parallel to each other. So when the two sides are parallel, we are saying that we have some figure whose opposite sides are parallel, then that becomes a parallelogram. But what we have to prove is, we have to prove that it is a rectangle. So we have to prove that one of its angles is 90 degrees. So we are talking about that the ray EF stands on the line AB. We are talking about this ray EF. We are considering this third figure over here. We are saying this ray EF, this stands on the line AB. We are considering AB as a line, and this stands on this ray. Ray means we are talking about this EF over here. This EF over here, this stands on this line. So what we have is that angle AEF, this angle we are talking about, this angle AEF and angle BEF. This is the angle BEF. Sum of both these angles will be 180 degrees. We are saying AEF plus BEF, that is equal to 180 degree. Now we know that these are the bisector of these angles, these smaller portions. These are the bisector of these angles. So what we are saying, suppose I am writing this equation over here. I have halved this equation and I get angle GEF plus angle HEF is 90 degrees. Why I am writing GEF over here? Because we know that when we are talking about the angle AEF, it is divided in two parts. One is AEG and second is GEF, and both these parts, they are equal because this line EG, that is the bisector. This line is the bisector. It means both these angles are equal. Similarly, both these angles are equal, these smaller angles we are talking about. So finally we get that angle GEH, that is equal to 90 degree. So we get EGFH is a rectangle. So we have to prove that opposite sides are parallel, and second thing, we have proved that their angle is 90 degrees. Now the next question we have is that in the given figure, it is given that the line L is parallel to M. This is line L and this is parallel to the line M, and T is the transversal. It is given that this angle 1 is 70 degrees. We have to find the measure of the remaining angles. So if this angle is 70 degree, so this will be equal to angle 5, because these two angles, these are corresponding angles. So the value of angle 5 is also 70 degree. Now we are saying if angle 1 is 70 degree, then angle 2 we are talking about, then angle 1 plus angle 2, that is 180 degree. And second thing is angle 1 plus angle 4 is 180 degree. So angle 1 is 70 degree. So what this implies is that angle 2 is equal to angle 4 is equal to 180 minus 70, that is 110 degree. So this angle is 110 degree. This is 110 degree. This angle we have obtained, it is 70 degree. Now if this is 70, then this is the vertically opposite angle. So this is also 70 degree. Similarly, we can find that this angle is 70 degree and these angles, these are 110 degrees. So these are the basic properties over here that we have to see which of these are vertically opposite angles, alternate angles and corresponding angles, and we use their properties to find the answer. Now in this question also, this is similar question as we have solved the last question. The only difference is over here the ratio between the angles 1 and angle 2 is given, it is 5:4. So if the ratio is given, we can write that angle 1 is equal to 5x and angle 2 is equal to 4x for some constant x. So what we get from this is this angle is 5x and this angle is 4x, and both these angles, they form a linear pair. So what we get is that 5x plus 4x is equal to 180 degree. So we get 9x is equal to 180 degree. So we get the value of x is 20 degree. So this angle we get, it is 100 degree, and this angle we get, it is 80 degree. Now from these angles we are saying this angle will be 100 degree because it is vertically opposite angle to this. Similarly, angle 4 will be equal to 80 degree because it is vertically opposite to the angle 2. Now, angle 6 and angle 4 will be equal. Why? Because these are alternate interior angles. Similarly, angle 3 and angle 5 will be equal. Alternate interior angle, we are saying these are two parallel lines, then these two angles, these are the alternate interior angles. So likewise we can calculate the value of all other angles. In the answer you will get, it is that angle 1 is 100, 2 is 80, 3 is 100, 4 is 80, 5 is 100, 6 is 80 and 7 is 100 and 8 is 80 degrees. Now the next question we have, in the given figure AB is parallel to CD. This line AB, it is parallel to CD, and if angle AOC, this whole angle we are talking about, if this whole angle is X and this angle BAO or OAB and OCD are 116 and 11104, so we have to find the value of X. So the figure that is given to us is that these two parallel lines are there. We are saying some point O is there and we are joining these two points. So the first thing we are doing over here, we are constructing a line OE parallel to AB and CD, we are saying, and passing through the point O. We are constructing a line over here which is parallel to both these lines. This is mentioned in this statement that through O draw OE and AB parallel to CD. So now what will happen is, we are talking about, if suppose I am talking about this much portion of the figure, so we are having two parallel lines and a transversal is there. Similarly, in this portion of the figure we are having two parallel line and a transversal. So basically we are saying this is point O, this is E, this is C and this is G, and in this figure we are having this point is A, B, O and E. Now the angle over here, it is, this angle is 104. So corresponding to this angle will be 180 minus 104 is equal to 76 degrees. So what we get is that this angle is 76 degree. Similarly, from the second figure we have this angle is 116 degree. So this angle will be 180 minus 116 degree, and that is equal to 64 degree. So we obtain that this angle is 64 degree. So sum of both these angles, we get this angle is 76 degree, this angle is 64 degree. So whole of this angle will be 76 plus 64, that is 140 degrees, and this is here, it is 140 degrees. Now the next question we have, again A, B and CD are the parallel lines and angle AOB, AB and CD are the parallel lines, and these two angles they are given to us. This is 40 degree and this is 35 degree, and we have to find the reflex angle BOD. So reflex angle BOD means we are talking about, we have to calculate this angle, this thing we have to calculate. So we have figure like this. So we are constructing a line over here, that is OE, which is parallel to both these lines. And now what we get is, we are saying that suppose this whole angle we are talking over here, that is EOB plus this whole angle, it is say X degrees. So what we have to calculate, we have to calculate the value of X. Now this angle is given to be 40 degrees. if I look at this portion over here, so what I get is that these are two parallel lines A, B and E, O, and we have a transversal over here. So this point is B, we have a transversal over here, and this angle is given to be 40 degree. If this angle is 40 degree, then the value of this angle will be 180 minus 40, that is equal to 140 degree. So this angle we are talking about, this is 140 degree. Similarly, this angle is given to be 35 degree. So in the lower portion we are saying this OD, we are saying it will act as transversal, and these are the two parallel lines. Now we have this angle is 35 degree, so corresponding to this angle will be 180 minus 35 is equal to 145 degree. So we obtain that this lower angle is 145 degree. So total value of x we have, the total value of x is sum of these two values, that is 140 degree plus 145 degree, that is equal to 285 degree. And it is greater than 180 degree, that is why it is called the reflex angle. Now in the next figure we are given the lines AB is parallel to CD is parallel to EF. We are saying these three lines, these are parallel to each other. So parallel lines we represent like this, you can draw the arrow over here. Next it is given that we have two lines PQ and RS, and these two lines are also parallel to each other. Then we are given the angles. We are saying RQD is 25 degree and this angle is 60 degree. We have to calculate the value of the angle QRS. We have to calculate the value of this angle. So what we see from this figure is, if I look at the terms over here and I extend these lines like this, and extend this line like this. So if I am talking about the lines say AB and the line CD, and I am talking over here, this is our transversal RQ. For this line we are saying the transversal we are considering it is, this is the transversal over here. So if we are saying this is the transversal and this angle is 25 degree, then this smaller angle will be 25 degree. So what we get is that this angle over here, this part of angle, this is equal to this angle and this is equal to 25 degrees. Now the next thing we are saying is that these two lines, these are parallel lines. So the angle given to us, this angle is 60 degree. So corresponding to this angle over here, this will be 180 minus 60 is equal to 120 degree. Now if I consider the line AB and I am talking about the line EF, and we are talking about this as transversal, this line that we have drawn over here. So if this angle is 120 degrees, then corresponding to this angle is also 120 degrees, and this angle is also 60 degrees. We are saying the angle that is given to us, this angle is 60 degree over here. We have extended this line. We are talking about this is this line T I am talking about, this is a transversal T. So this angle is 120, so this angle is also 120 degree, and corresponding to this angle is 60 degrees. Now what we are left to find is we want to find this angle. So for this angle we are considering this part over here. I'm talking about this part over here. So what we have now is we are saying we are having two lines. So this is T we are saying, and there is another line over here that we have written over here, S and R, and this line, these two lines, these are parallel lines, it is given to us, and AB will act as a transversal for these two lines. Now from this figure what we have is that this angle over here, it is 60 degree. So if this angle is 60 degree, then this angle is also 60 degree, and this angle will be 180 minus 60, that is equal to 120 degree. So what we get is we have obtained the value of both the angles. We are saying that this smaller part over here, this is equal to this 25 degree, this part is 25 degree, and this angle we have obtained, it is 120 degree. So the total angle we have over here, it is 120 plus 25 is equal to 145 degrees. Now the next question we have, it is AB is parallel to CD. This is given to us, this line AB, it is parallel to CD, and the angles over here, this angle is 120 degree and this angle is given to be 100 degree, and we have to calculate the value of angle X. So we are saying that what we are going to do, we have constructed this line, we have extended this line in this direction, and we have constructed this line EF, we have extended the line EG. So this is a construction part over here, that through E draw a line FEG parallel to the line AB and CD. So now what we have is, suppose I am looking at this line BE over here. So this is transversal T1 I am writing, and suppose I am talking about the line, this second line I am talking over here, this is that transversal T2. So if I look at this portion over here, what I have is that AB is there and FE is there, and at B we are having a transversal. So if this angle is 120 degree, then corresponding to it this angle will be 60 degree. Why? It is 180 minus 20 degree. They are co-interior angles. Similarly, if we look at this portion over here, then we have the lines CD and EG, and we have a line over here. We are saying, suppose this is the line, this is the point E. So we are saying this is the transversal T2. This angle is 100 degree. So corresponding to it, this angle is 180 minus 100 equal to 80 degree. Why? These are co-interior angles. So we get the value over it is 80 degree. So we have obtained that this angle over here, this angle we are talking about, this angle is 60 degree. This angle over here, we are saying this angle is 80 degree. Now all these three angles, these three we are talking about over here, all these three angles, they lie on a line FEG. So what we get is that 60 degree plus X degree plus 80 degree, that is equal to 180 degree. So when you solve these equations, you will get 140 plus X is equal to 180 degree. So the value of X you will get, it is 40 degree. This is the value of X we are having now. Now in the next question, it is given that AB is parallel to CD, and these angles are given. This angle is 50 degree, this angle is 100 degree, and we have to calculate the value of X degrees. So what construction we are going to do is, the figure that is given to us, it is just this, that this is AB. We are saying this is line over here, this is CD. We have joined these two, and this is E over here. These two lines, these are given to be parallel, and this angle is given 100 degree and this is given to be 50 degree. So what construction we are going to do? We have constructed a line over here which is parallel to both. This line GH we have constructed, it is parallel to both CD and AB. So when we construct this line, so again what we have two transversal over here. One transversal we are talking about this is transversal T1, and second we are talking about the transversal over here, this is transversal T2. So we are talking about two cases. One is this line is there and this line is there, and transversal T1 is there. Second we are talking about two lines are there, and this is the transversal T2. This is the point C, this is E, this is the point A, and this is E. So what we have now is that this angle is 50 degree. So correspondingly the angle we have over here, this is 50 degree. So this angle we have, it is 50 degree. Similarly, when we are talking about the second one, this angle is given to be 100 degree. If this angle is 100 degrees, then this angle will be 180 minus 100 degree. Co-interior angles over here, these are the alternate angles. In this, these are the co-interior angles. So the answer you will get, it is 80 degree. It means this value over here, this is 80 degrees. Now these three angles we are talking about, 50 degree, X degree and 180 degree, they lie on a line GEH. So it means their sum 50 degree plus X degree plus 80 degree, their sum will be equal to 180 degree. So the value of X you will get, it is equal to 50 degrees. This is what we have to find. The value of X we have to calculate, and the value of X is 50 degree, and if we are writing X degree, that is equal to 50 degree. Next we are given two parallel lines A, B and CD. Then a point E is given, and corresponding to this point, the angle given are, this angle is 105 and this angle is 25 degrees. We have to find the value of X. This value of X we have to calculate. So we are saying that this line AE is a transversal for, first of all we have done the construction, that is we have from E we have drawn this line EF. This is, we have constructed this line, it is parallel to both these lines. Now if I am talking about that I have constructed another line over here, say I am saying I have extended this line AE in this form, and I am saying this is some transversal T for the parallel lines. I am talking about these two parallel lines, that for the line BA and EF, this is E over here. So for both these lines, this T is the transversal. So if this angle is 105 degrees, then corresponding to it, this angle, this will be 180 degree minus 105 degrees. This whole angle will be equal to 180 degree minus 105 degree. Now this part of the angle is given to be 25 degrees. So what we are left is, if we want to find this angle over here, so it is 180 degree minus 105 degree minus 25 degrees. So the answer we will have, that is, this angle is, the smaller angle we have, it is 150 degrees. Now if we consider this portion of the figure, what we have a line CD over here. This is the line CD, and we have the line EF over here, and we have a transversal over here. We are saying this is the transversal, we are saying this is the point E. Now what we have, this angle is 50 degree. These two lines, these are parallel, so this angle will be equal to 180 degree minus 50 degree, that is equal to 130 degree, and this is our answer, that x degree is 130 degree. So value of x we have, it is 130. Now in the next question, we are given two plane mirrors M and N. We are saying these are the two plane mirrors. This is the mirror M and this is the mirror N, and they are placed parallel to each other. So it means both these lines, these are parallel to each other. And then we are saying a ray AB is incident on M, it gets reflected over here, then this becomes N. When we are talking about this is the incident ray for M, and this is the reflected ray for M. This ray is the incident ray for N, and this ray will become reflected ray for M. Now from the properties of the mirror, we know that if we draw perpendiculars over here, we have drawn the perpendicular CN and we have drawn the perpendicular MB. Then these angles we are talking over here, these angles, the angle of reflection, the angle of incidence and angle of reflection, they will be equal. So what we get is that angle from this, we will get angle of incidence is equal to angle of reflection. From this we will get it is angle of incidence is equal to angle of reflection. Now if we consider the two parallel lines CN and MB, then we have CB as the transversal over here. So we are talking about the line CN and MB, and this is the transversal over here. So for this transversal, we are saying that this angle 3 and angle 2, they will be equal because they are alternate interior angles. Now we have three results over here. First is that angle 3 is equal to angle 4, then angle 1 is equal to angle 2, now angle 2 is equal to angle 3. So what we get is that all these angles, we are saying angle 1 equal to angle 2 equal to angle 3 equal to angle 4. So what we get from this is that sum of these two angles, all these angles, these are equal. If I am saying this angle is x, this is also x, this is x, this is x, so this larger angle is 2x and this larger angle is 2x. So what we have is, I am talking about in the third figure, this angle we have, it is 2x, and this angle we are saying it is also 2x. Now consider the lines over here. This line CD is there and this line AB is there. Now we have again this T is the transversal over here. Now for these three lines, we are saying these alternate interior angle, they are equal, and the result we have is if the alternate interior angles are equal, then it means that both these lines will be A, B and CD, they are parallel to each other. And this is what we have to prove in this question. In the next question, it is given that if the arms of one angle are respectively parallel to the arms of another angle, then we have to show that the two angles we are talking about, they are either equal or they are supplementary. So what we mean over here is that we have three cases in which the angles can be arranged, we can say. So first case we are talking about, it is that the two angles, they are in this form. The two angles, they are in this form. We are saying the one angle is ABC and the second angle is DE and F. The second case we have, it is that ABC is here and angle DEF is over here. Now what we see from this is that the sides are, these sides are parallel, in this these sides are parallel, these two sides, these are parallel to each other. Similarly in this, these sides are parallel and these sides are parallel to each other. Similarly in the third case we are saying it is like this, that these two sides are parallel and these two sides are parallel. So we have to prove in all these three cases that either the two angles, they are equal or they are supplementary. So for the first case we are considering over here, when both the pair of arms are parallel in the same sense, we are saying we are having the angles like this. These are the angles. Now if I consider this line and this line, I am talking about this is a transversal for these two lines. So what we get is, if this angle is angle 1, then this is also equal to this angle. Both these angles, these will be equal. Now in the second case we are saying that we are considering this line and this line. Both these lines, these are parallel, these two lines, these are parallel, and this is the transversal, this line over here, this line T over here, this is the transversal for these two lines. So what we get is that the angle over here, this angle, this is also equal to angle 1, because this is now the these two angles are equal, these two angles are equal. So what we get is that angle 1, this is also angle 1. So in both, in this particular case, when we are saying that the arms are parallel, both these angles, they are equal. Now we come to the second case. Now the second case is when both pair of arms are parallel in opposite sense. So parallel in opposite sense means we are saying that if this arm, we are talking about BA, this is, we are saying in this direction, and the arm of the second angle, it is in this direction. So that is why the sense means that the direction of both these rays, they are opposite. But these lines, as lines, this line is parallel to this line and this line is parallel to this line. Now when we are considering this case, we are talking about that BA, this BA, that is parallel to ED, and for these two lines we have BC as the transversal. For these two lines, this is the transversal. So if this angle is 1, we will get these, this angle is also equal to 1. Similarly, if we are considering the parallel lines, we are saying the two lines we are considering, it is FE and BC. We are considering these two lines now, and for these two lines we have this line ED as the transversal. This line ED is the transversal over here. So for this transversal, we are saying, we are considering, now this is the transversal, there are two parallel lines and this is the transversal. If this angle is 1, we will have this angle is 1. So both these angles, these are equal to 1, angle 1. So what we get, that this angle and this angle all are equal, and finally we get both these angles, they are equal. Now the last case we have is when one pair of arms are parallel in same sense and other pair in the opposite sense. So what we are saying, if this is in this ray AB is in this direction, we are saying the ray ED is also in the same direction. Now the ray EF, it is towards the left, but the ray BC we are talking about, it is towards the right. So because of this we are saying one of the rays is in opposite sense. Opposite sense basically means we are talking about the direction of the ray. We are talking about the direction of the ray. Now in this case we are having two parallel lines. We are saying BA and ED. One line we are talking about is BA and second we are talking about is ED, and for these two lines BC is the transversal line. So what we get is that the angle EGB, that is equal to angle ABC. If we are saying this angle is angle 1, then this angle is angle 1. Now if we consider the two parallel lines, one we are considering BGC and second we are considering EF, we have DE is the transversal. Now if this is the transversal, so what kind of situation we have is that we are saying we have two parallel lines, a transversal is there, this angle we are saying it is equal to 1, then the value of this angle will be 180 degree minus angle 1. So we are saying that this angle will be 180 degree minus angle 1 because these are corresponding interior angles. So what we get is the sum of angle ABC and the angle FED, that is equal to angle 1 plus 180 degree minus angle 1, so that is equal to 180 degree. So it means sum of both these angles is 180 degree. So if the sum of the two angles is 180 degree, they are called the supplementary angles. Now next we have to prove is that opposite angles of a parallelogram are equal. So we are saying we are given a parallelogram ABCD in which the side AB is parallel to DC and AD is parallel to BC. We have to prove that the opposite angle, that is angle A, is equal to angle C and angle B is equal to angle D. So if we consider the two parallel sides, we are talking about AB and DC, then we have AD is the transversal over here. Now for this transversal, suppose I am saying that angle, this angle is angle 1, this is say angle 2, or you can write it as A, this is angle B, D, this is angle C, and this is angle B, this is D and this is this. So for this transversal we have sum of these two angles, these will be 180 degree because they are alternate interior angles. We are saying these two are parallel lines, there is a transversal, this angle we are saying this is angle A and this angle we are saying this is angle D, and we know that the sum of these two angles is 180 degree. Now again if we consider that this is the line AD we have and there is a parallel line BC, this is parallel to BC, and now the transversal we are considering it is DC. So what we have in this case, we are talking about two parallel lines are there and a transversal is there. These two lines are parallel and a transversal line is there. We are saying this angle we have it is angle D and this angle we are saying it is angle C. So again we have D plus C will be equal to 180 degree. So what we get is that angle A plus angle D is 180 degree, angle D plus angle C is 180 degree. So when we subtract these two equations, this D gets cancelled with D and we are left with angle A minus angle C is equal to 0. So this implies us angle A is equal to angle C. So we get both these angle A and angle C, they are equal. Similarly, we can prove that angle B and angle D, they are equal. And this is what is we have to prove in this particular problem. Now in this next question, we are given three parallel lines, that AB is parallel to CD is parallel to EF, and the angles are given us, the value of DBG is X and EDH is Y and AEB is Z. Further, this angle EAB is 90 degrees and angle BEF is 65 degrees. These are given in the figure, and we have to find the value of X, Y and Z. So we start with this, that this line and this line, they are parallel, and this is a transversal over here. So we are saying that the sum of these two angles, this angle 65 degree and this angle Y degree, the sum of these two angles will be 180 degree. So we get the value of Y is 115 degree. Now next we are considering the line CDH and ABG. We are considering these two lines. For these two lines, again this line BDE, it is the transversal. So what we have is this angle and this angle X, these will be equal. So what we get, why? Because these are corresponding angles. So the value of X you will get, it is 115 degree. Now if we look at this line ABG, we are saying at B it is this angle formed over here, and this angle X, they form a linear pair. So as they form a linear pair, we find that the value of this angle, we have it is 180 degree minus 115 degree, and that is equal to 65 degrees. Now we have a triangle over here. This angle is 90 degree, this angle is 65 degree, and we have to calculate the value of this third angle Z, and we know that the sum of angles of a triangle is 180 degree. So we get 65 plus 90 plus Z, that is equal to 180 degree. So we get 155 plus Z is equal to 180 degree. So the value of Z you will get, it is 180 minus 55, that is equal to 25 degrees. So these are the value of X, Y and Z that we have. Now in the next question, it is given that AB is parallel to DE. So we are saying AB is parallel to DE is given to us, and we have to prove that angle ABC plus angle BCD is equal to 180 plus angle CDE. So to solve this, we are saying we are doing a construction, and we have drawn a line over here. This is F. So when we draw this line, now we are talking about, we have basically how we have drawn this line, that this is parallel to AB and this is parallel to the line DE. Now we have two cases over here. In the first case, we are having this line FC and this is AB, and we have, this is the transversal line. Similarly, in the second case we are saying it is DE and this is CF, and this will act as the transversal line. If suppose I am talking about this angle is angle 1, this smaller angle I am saying this is angle 2, then this next angle I am saying this is angle 3, and the next angle I am talking about, this angle, it is angle 4. So what we have is that this is angle 1 and this is angle 2. So we have angle 1 plus angle 2, that is equal to 180 degree. Next, this is angle 3 and this is angle 4. We have angle 3 is equal to angle 4. Now what we have to prove is, we have to prove that if I will write in terms of angle 1, 2, 3, the problem, it is angle ABC, that is angle 1 I am talking about, then it is BCD, means I am talking about angle 2 plus angle 3, this value, then it equal to 180 plus angle CDE, and it is angle 4. So what we are saying is, if we look at this equation, what we are trying to find is, we add these two equations and we will get angle 1 plus angle 2 plus angle 3, that is equal to 180 plus angle 4, and this is what we have to prove. Now in the next question, the angles are given to us. It is given that angle ABC is 80 degree, angle DEF is 45 degree, and then it is given that the arms DE and EF, we are talking about the arms DE and EF of the angle DEF cut BC at P and Q. We have to prove that PD, we are talking about PD is this, we have to prove that PD is parallel to AB. We have to prove that PD is parallel to AB. So how we are going to solve this is, we are saying that if we consider this triangle PQE, we are talking about PEQ, this angle is 35 degree, this angle is 45 degree. So we can find the value of this angle. It is 180 minus 35 minus 45 degree, that is equal to 100 degree. So we get the value of this angle P, we have, this is 100 degree. Now if I look at this angle over here, I am looking at this angle, we are saying, suppose this, the value of this angle is x degree, then x and 100 they form a linear pair. So the value of x I will get, it is 180 minus 100, that is equal to 80 degrees. Now look at these two lines. One line I am talking about is AB and second I am talking about is DE. For these two lines we have DPQC as a transversal. We have this line as a transversal. And second thing we have is, this angle is 80 degree and this angle is 80 degree. So their corresponding angle, they are equal. So when the corresponding angle corresponding to these two lines, we are saying they are equal, then our corresponding angle axiom says that these two lines, these are parallel to each other, and this is what we have to prove. Now in the next question, it is in the figure AB and CD, they are parallel and angle CDP is 35 degrees given to us. Then it is given that PD, we are talking about this PD, it is produced downward to meet AB at E, and this angle is given to be 75 degrees. Further it is given that DQ, that is parallel to EF, and we have to find the angles AED we have to find this angle. Second, we have to find the angle DEF. We have to find DEF and we have to find PDQ. We have to find these three angles. So we start solving this problem by considering the two parallel lines. We are considering the line CD and we are considering the line, this is the line CD and this is the line AB, and then we have a transversal over here. If this angle is 35 degrees, I'm talking about this angle, then we have this angle is also 35 degree because it is corresponding angle. So we get that the value of this angle is 35 degrees. Now these three angles, their sum will be 180 because they lie on a ray, or we are saying they are lying on a line AEB. So what we get is that if suppose I'm talking about this angle, suppose this is x, so we get 35 plus x plus 75 is equal to 180 degree. So the value of x you will get, it is 180 minus 110, that is equal to 70 degrees. So value of x you will get, it is 70 degrees. Now I am talking about these two lines over here. So one line I have, it is QD, and second line I have over here, it is FE, and for both these lines we have a transversal over here. So this line I am saying it is ED. So if you look at the figure, we are drawing, this is the line QD, this is the line FE, this is QD and this is FE, and then we are talking about this is the transversal over here. Now what we have is that this angle is 70 degrees, so this angle will also be equal to 70 degree because these two are the corresponding angles. So we find the value of all these three angles. So this angle is 70 degrees. So we get the answer as this angle is 35, this is 70 and this is 70 degrees. Now in the next question, we are given that AB is parallel to CD and angle A is 90 degree and angle AEC is 40 degree. We have to find the value of angle ECD. So first of all, what we are going to do is we are going to draw through CF perpendicular to AE, cutting AB at G. So what we have done, we have drawn this line over here. This is the construction. So this is the construction that we have done. Now what we have is that CF is parallel to AE, the line that we have drawn over here. This is parallel to AE, and the line EC, this line EC, it is transversal over here. So what we get from this is, if this angle is 40 degree, then this angle is also equal to 40 degree. Now next, for the same two lines AE and FGC, we are now considering the transversal as AGB. Now if this angle is 90 degree, then this angle is also 90 degree. We are talking about these two lines over here. We are saying this is the line EAE and this is the line we are talking about, it is CF, this is the point G and this is B over here. We are saying if these two lines we have drawn, these are parallel lines. This is by our construction. Now if this angle is 90 degree, this is the corresponding angle. So this angle is also 90 degrees. Now the two lines A, B and CD, they are given to be parallel. It is given to us that AB and CD, these two lines, these are parallel, and for these two lines, this line FC, for these two lines, this line FC, this will act as a transversal. Now what we have is, this angle is 90 degree, so this angle is also 90 degrees, because again these two angles, these are the corresponding angles. This is the transversal and these two lines, these are parallel lines. So what we get is that this angle over here, this is of here 90 degree. So the final answer we will get it is, this angle is 40 degree, this angle is 90 degree. The final answer we will get that angle ECD, that is equal to 90 plus 40 is equal to 130 degrees. Now in this question, it is given that the line AB, that is parallel to the line CD, and angle GED, this larger angle, it is given as 125 degrees. And the next thing that is given to us is that EF is perpendicular to CD, and we have to find the value of these three angles. So if we take GE as a transversal for the line AB and CD, we get that if this angle is 125 degree, then this angle is also 125 degree, because these two angles, these are the corresponding angles. Now for this portion I am talking about, if you look at this portion, we are having, this is D, G and E, and we have a perpendicular over here. So we are saying this angle is 90 degree, this larger angle is 125 degree. So this angle, this will be equal to 125 minus 90, this is 90 degree angle. So it is 125 minus 90 is 35 degrees. Now the next we have is that both these lines AB and CD, they are parallel lines. Now if we consider FE as the transversal, we have this angle over here, this angle is 90 degree. So this angle is also 90 degree, this angle is also 90 degree, because these two angles, these are alternate interior angles. Further, if this angle is 90 degree, this is a straight line over here, so the value of this angle is also 90 degree. Now the angle we require is this, it is FGE, so the value of this angle will be 180 minus 125 degrees, that is equal to 55 degrees. You can directly calculate this angle from this portion. We are saying that this angle is 125 degree, the sum of both these angles will be 180 degree. So the answer for this angle is 55 degrees. Hence we have obtained the answer for all three angles. The first is 125, next is 35, and the last one is 55 degrees.